give the chemical reactions of pyridine and oxide, halogenation, nitration, and you have amination. Right. So first reaction we will be looking into is called as halogenation. Halogenation मतलब क्या? Addition of X minus. करेक्ट है? तो अभी हम लोग किस पे अटैक कर रहे हैं? pyridine N ऑक्साइड. ठीक है? This is your pyridine N oxide. Okay. Structure is understood. X minus can be obtained by SOCl2 or phosphorus oxychloride. This will give rise to pyridine. Now, I have told you yesterday that there are few positions which are more susceptible for electrophilic substitution. Position number 2, position number 4, and position number 6. So, you are doing halogenation, your Cl will be joined over here. This is your pyridine. So, this is called as 2-chloropyridine. Now, you can have few racemization also. It can also happen that your chlorine might go to this position. So, this is also correct. And the name will be 4-chloropyridine. Second reaction is going to be under halogenation. You can also have one more, that is bromine. Bromination takes place in the presence of oleum. Okay. Bromine is the only group which will not attack second or fourth position, but it is going to sit on the third position. तो ये आपका यहाँ पे बैठेगा ब्रोमीन. ठीक है? This will be 3-bromopyridine. हाँ, so next reaction is called as nitration. In nitration, you always have to use concentrated nitric acid and concentrated sulfuric acid. Okay? For nitric acid, you should use fuming nitric acid. Then and only then the nitration reaction takes place. So this reaction is a high temperature reaction which takes place at 160 degrees. This is your pyridine N oxide. And it is going to undergo nitration using nitric acid and using sulfuric acid at a temperature of 160 degrees Celsius. You will have the attachment of nitro group. Right? Now, अभी इसमें क्या हो रहा है? Nitro group has nothing to do with the N oxide part. Whereas in halogenation, if you observe, my end product was pyridine. Okay. In nitration, your N pyridine oxide will be retained till the end. Okay. There is a concept called as activating and deactivating of the benzene ring, which I will be teaching you in the subsequent lectures. ठीक है? तो उसकी वजह से नाइट्रेशन में क्या होता है? आपका pyridine जो अपना N oxide जो है, वो retained रहता है. Now I am talking about the third chemical reaction, which is called as amination. In amination, I will be taking my pyridine N oxide and I will be reacting it with a very, very rigorous agent that is called as soda amide. It is an exceptionally strong base. Okay. Now, this takes place in solvent ammonia. Okay. Now, what am I going to add is, I am going to add amino group because the reaction says it is amination. So, positions 2 and positions 4 are used for this. One will be over here and the other will be over here at 4th position. So your amino group is over here. So there are 3 reactions in studying with pyridine N oxide. Chemical reaction number 1 is halogenation. Halogenation means you're going to just add a halogen, in which I have used 3 different reagents. I have used sulfur, SOCl2 is thionyl chloride. POCl3 is phosphorus oxychloride. Third reagent is bromine in presence of oleum. All the 3 are undergoing halogenation reaction with giving you subsequent products. With respect to this, it is chlorine. And if I'm using bromine, then I am getting bromine in the end product. Next reaction is nitration reaction. Nitration reaction takes place only in the presence of concentrated nitric acid and concentrated sulfuric acid at high temperature. So, over here, my nitric acid should also be fuming nitric acid. Then and only then your nitration reaction will work out. So, this is going to give me rise to a nitro group at the 4th position. Third chemical reaction is called as amination reaction. In amination reaction, I am going to use exceptionally strong base called as soda amide. This takes place in the solvent called as ammonia, and it gives rise to 2 products, that is at the 2nd position and the next is at the 4th position. Because we all know that pyridine N oxide undergoes electrophilic substitution in positions 2, 4 and 6. Is this much very clear, children?